Hey guys, this is Abhishek, and I am an associate of Planet Earth Research Consultants, and I welcome you all to a presentation on brief introduction to engineering materials. It is an interdisciplinary branch of material science and metallurgy. In today's world, there exists wide variety of materials to cater industrial and household needs as raw materials or as finished goods. So, what makes material science so important? In an engineer's perspective, a material has to be stronger, economic, lightweight, more functional, sustainable, and quality oriented. So, as to achieve this, engineers have to design the product or the components or the system considering the type of material and the manufacturing process or the technology which is more ideal. The type of material and its selection is very vital to an engineer. These are certain key criteria that can be followed. Properties and characteristics. Physical properties can be the appearance, the color, the weight and density, and there are a lot more other features. And another important property would be the mechanical property, which involves the strength, toughness, malleability, ductility, and there are a lot more other properties which will be dealt. And then it involves chemical properties, which could be the composition of the material. And next is the application area, the advantages and the limitations of the materials, the manufacturability, and the processes that is involved to manufacture the product. This could be the primary, secondary, tertiary, or the non-conventional processes of manufacturing. The aspects of mechanical properties and manufacturability through processes will be presented in the subsequent videos. The availability of the material is another important criteria, where the shape, size, the quantity, and the supply of the material depends. The cost consideration and also the service life of the material. As such, it is very important to understand how engineering materials are classified. Engineering materials are basically classified into metallic and non-metallic materials. Metallic materials are those which are malleable and ductile, and non-metallic materials are non-malleable and non-ductile. Metallic materials are associated with igneous and metamorphic rocks, while non-metallic materials are associated with sedimentary rocks. Metallic materials shows luster, while non-metallic do not. Further, metallic materials are classified into ferrous metals and non-ferrous metals. These ferrous metals contains iron as major constituent, while non-ferrous metal do not contain iron. And most of the ferrous metals are magnetic in nature, while non-ferrous metals are non-magnetic in nature. Ferrous metals has very low resistance to corrosion, while non-ferrous metals are highly resistant to corrosion. Steel and cast iron have been a dominant material in the engineering world. These ferrous metals are widely used in industrial and engineering applications. Non-ferrous metals like copper and aluminium are used for their ability to conduct electricity. So ferrous and non-ferrous materials are basically used in structures, in automotive industry, in marine industry, in defense, in appliances manufacturing, in vehicle manufacturing, in toys, in tools, utensils, architectural applications, and into consumer products. These non-metallic materials are further classified into organic and inorganic materials. The organic materials contains carbon atoms and or may also contain hydrogen atoms, while inorganic materials do not contain carbon or very less compounds of it. Organic materials are colorless, while inorganic materials are colorful. Organic materials are hydrophobic in nature. Inorganic materials mostly can dissolve in water. In the organic materials, we find polymers, that is, the plastics and the rubber, which are widely used. The plastics, which are synthetic or semi synthetic organic compounds, and they are more malleable and they can be molded into solid shapes. So, these are the classification of basic engineering materials. Engineers are in need or in search for better materials with a combination of different properties. The unusual combination of properties cannot be met by conventional metal alloys, ceramics, or polymers. The combination of two or more materials, usually with dissimilar characteristics, different forms, different chemical composition, which are insoluble in each other, may be referred to as composites. These composites are macroscopic in nature, while the basic engineering materials are microscopic in nature. So these composite materials are formed in distribution or in reinforced matrix. There are two types of composites, which are reinforcements and matrix formation. These reinforced composites usually utilize polymers, ceramics, metal matrices, while the matrix formation usually are of fiber, laminates, and particulates. Here we can see a reinforced concrete cement column with composite bars, which is a type of composite material. You can see Boeing 777 aircraft where it uses different materials. You can also see a rubber miniature, which is a 3D print nanostructure. And you also see carbon fiber reinforced products, which are used in manufacturing body parts of automobile, electronic devices, and many more. The emerging scientific trends in materials has shown tremendous potential in reusability of inorganic and organic wastes, energy production, nanotechnology, 3D printing, building materials that could be used in the space, and many more. Thus, enabling robust manufacturing for defense, automobile, aircraft, power industry, medical industry, pharmaceutical industry, and variety of other industries. I thank you for watching, guys.